And now let's begin tracing the JUnit test case in both the debugger and concurrently with the paper. Let me show you what I have set up on the paper, and that's something you can also try to do on your piece of paper on your own. So we got, like last time in part 1, we got the template definition for entry, and we got the 2 attributes, we got the constructor, and also we got some selective list of mutators and accessor. We got accessor here, mutator here, and also the overloaded mutator, and also the accessor toString. So these are useful for these are relevant to our tracing. And also we got the JUnit test case on the right hand side. So this is more like a user of the model class to manipulate object creations and also method calls. And specifically we want to trace TestEntry 2, and we want to see how we can set the entry's products the first time, and then the second time, and then the third time. So this is what we would like to see throughout the course of the code. And let's now set up the debugger as well on the Eclipse. Make sure you move to the beginning of TestEntry 2, and we want to set a breakpoint at the first line of the test method over here, the first line, right before we try to execute the creation of these objects and store that into P, right before. And what I will do is I'm going to launch the debugger over here, or alternatively, you can right click on test products. Oh, sorry, TestEntry, of course. Make sure you right click on the right class. Right click on select TestEntry, and you can say debug as JUnit test. And then make sure you switch to the debug perspective, and now we are now set to actually go between the paper and the debugger. Let me now try to step over a few lines first of all. And for this few lines, so this is something that I have done earlier before in the part 1 in the last video about how to trace these method calls and object creation. So I'm going to skip those, and the way to skip those, I will show you something very useful. Let's say I really don't want to say step over, step over, step over, step over, step over, and step over for so many times. What I can do alternatively is to say I want to just use one single click, and then I want to skip all the way to before executing this line. Let's say that's what I would like to do. So what I will do is I'm going to set a breakpoint as I just did, and then rather than saying step over, I'm going to click on step return. Step return simply means you're going to skip all the steps in front of you until the next breakpoint. That's basically what step return really means. Okay, so what can we anticipate? You can see currently under the variables, we don't have any P because we haven't executed this line just yet. But as soon as I say step return and then skip everything in front and then go all the way to the next breakpoint, what's going to happen is I'm going to get P storing the address of some product objects, and then it's going to have all the attributes set accordingly, and also with the initial setup here, right? That's what I can expect. All right, so let's now do it. I can say step return over here, the rightmost button here. If I click on that, so now I'm now here 47 right before creating the entry objects. And let's take a look at P over here. You can say for P, if you click on that, remember, it's going to show you the toString return value from this object because we redefine the toString method in the product class. If you expand the object view over here, we do know what the corresponding diagram looks like on the paper, which I will show to you as well. And you can see these are all the attribute value that have been set already. And notice one thing here, the iPad Pro 12.9, the model, and also the original price, which is over here. So these 2 attributes were set by the constructor over here, whereas all the other attributes were set by the mutators, right? Just clarify, like the timings of them being set up. All right, let's see how that would look like on our paper quickly, right? So what we'll do is we're gonna execute this line over here, the first object that we want to create for products, which will be, let me use this blue here, this line over here. Okay, so this is the line we want to do, and also we want to execute all the other mutated calls as well. So what are we going to have? And we're going to have an object of type products. Okay, so I just got something I pre-drew over here, and just remind yourself, you actually got 6 different attributes for the products. You got model, you got finish, you got storage, you got cellular connectivity, you got original price, you got discount value. Just remind yourself, okay? And to be more consistent with the color, I will color this as blue, so that we will know this is the objects as a result from this blue line of creation over here. Okay, let me just change the color quickly. So this should be blue over here. And then we actually store the reference or address of these objects into P, right? So that's a variable name, P. So we got P over here is pointing to this object over here. That's what we have done. And then, of course, we can set up the attribute value very quickly. So that'll be iPad Pro 12.9. And then we got original price 1709. 1709.00. And then the finish will be space gray over here, and etc. Right? Let me just put it down just for completeness. Space gray, and also the storage will be 1000, and then it will be true for the cellular connectivity, and also discount price, let's see, 220. Right? You can see every value over here that's being set over here. All right, should be no surprise to you. Let's now move on. What about executing this line over here, which I will mark in a slightly darker blue over here? How do we visualize this line over here? So this line is about creating a new entry objects, which we didn't do in part 1, of course, because this class didn't exist back then. So what this will do is it's going to create an entry class and store entry objects, and then store its address into object variable E. And how should we draw an object of type entry? Of course, we're going to call the entry constructor, but we'll do that for sure. So this is the entry constructor that we're going to call. But how do we visualize its objects? It depends on the list of attributes of the entry class, which includes these two attributes, right? So there'll be two parts over here. Specifically, string is a reference type from the Java API library. Product is also a reference type that's actually from our current projects for the Apple shop, right? I'm just repeating the points I mentioned before. Hopefully that can help you reinforce your understanding. So how do we draw that? So what I will do is I'm going to draw an object, a box over here, and then the type of object I'm trying to visualize is entry, right? Because we're creating an entry object over here, so that'll be entry. And then we know that entry has two attributes, so there'll be two compartments of the entry object here. So one would be serial number, the other one would be products. So serial number and also products, okay? And the serial number is simply just this value over here, right? F9DN4 and etc. F9DN4 and etc. Right? But for this particular example, we don't really change the serial number, so that's okay. So you understand this is serial number I'm referring to, and this line over here is really important. This one here, right? We are passing an argument P, which stores the address of this new object that we created before, right? Just remember. Okay. So how do we execute that? Well, we're calling the constructor over here, exactly what I just boxed over here. And then specifically, the argument product is going to be replaced by P. And then every occurrence of product is also going to be replaced by P. And what's this? This should be the context objects. And the context object that we are talking about is this particular new object of type entry that whose address will be stored in E. So meaning that we're going to have E pointing to this particular object. So E is really the context objects in this case, right? Just remember the term context objects, very important. Okay, so we're going to replace this over here by E. So what it boils down into is the following assignments, which I'll put it here. So that'll be E.products is assigned to P. And how do we visualize the effects of this line of code? Well, let's remind ourselves very quickly. Remember from the earlier page over here, we spoke about how you can interpret P2 is assigned to P1. So that would mean P2 will be pointing to wherever P1 is pointing to, and we'll do exactly the same interpretation. So now that means after doing this particular assignments, E.products is going to point to wherever P is pointing to. Wherever P is pointing to is over here. So now after assign P into E.products, so E.products, right? Remember dot is for you to look up the address of the memory and look for the corresponding objects. And E.P is going to point to wherever P is pointing to. So that's basically the consequence, right? Let's now draw that, okay? And since we are pointing to this particular object, so let me use the same color. So let me use the light blue over here. So now after executing this line over here, E.products, which is this field over here, which always store the address of some products objects. So this one is now going to point to wherever P is pointing to. So this is the consequence of doing this, right? So guys, this is a very important point to actually note. You should really understand exactly what this means. If you got any doubts, let me know, and I can do the illustration maybe in a slightly more different way for you. All right. So after this, we can now do some assertions. Why don't we try that? Okay. So let's now try to do some assertion here. The first one I would like to do. The first one, let's say assert equals, and then the serial number, that's the expected value, and how do we call E.get serial number? Okay, this one we talked about how you can make method call, right? Before. So E dot is going to locate this particular objects, and then we're going to invoke get serial number method on this particular objects. That one is very easy because we know that get serial number, I don't really have it here in the code, but you can look it up back to your Eclipse. And that one there is simply just going to retrieve the value for this attribute. So that'll be exactly this. So this one can easily pass. What about the next two assertions, which will be very interesting? Let me just highlight them over here in different color. Assert true, for example, over here. And then we say that E.getProducts equals P. Okay, let's now do the left-hand side of the relational operator. So E.getProducts, again, E dot identifying these objects, and then getProducts. GetProducts is this particular method. What that will do is it's going to return, remember there was an implicit this. So it's as if we got this dot product over here. And this is going to be replaced by the E over here, right? So it's as if we said E.products. What is E.products? E.product is referring to this field, specifically E.product, and that one is really referring to this object over here. That's the left-hand side. All right. And what about the right-hand side? The right-hand side is referring to P over here, and P is referring to just the same objects. So that's why this assertion, this Boolean expression here should be true. All right. So if you got any doubts, you can rewatch what I just said. Okay. Hopefully that's clear enough. So this part here, E.getProducts equals P. Compare is trying to compare if the two addresses actually refer to the same objects. So it's really checking for aliasing. So this will be true. Okay. So now we already got aliasing over here up to this point. So the aliasing we got. By the way, aliasing comes from the real world phenomenon. A person may have different aliases, especially a criminal actually. So a criminal may actually have their real name on the passport, and also they may have some other names which they live by, so they can commit some crime, right? That's kind of the analogy we borrow into CS. So whenever we talk about object aliasing, we simply mean for the same objects over here, they might live with different names, either the name of P or the name of E.products. So in this case, the object has two names. Of course, the name might change dynamically as we do some variable assignments. That's the principle. Okay. So now up to this point, the aliasing we have is both P and E.products reference the same objects. Okay, we're gonna have some similar aliasing situation in a moment by changing the pointer, but we'll see that. Okay, and similarly, if you do the next assertion about assert the same, right? The meaning is exactly like what we just explained before. When you say assert the same, and then you want to say e.getProducts and p, you're saying that these are referring to the same objects. Indeed, they are. E.products is referring to this object here, and p is referring to this object as well. Of course, that should pass. Okay, and let's now go on to assert equals very quickly. What about assert equals over here? Now, that's worth explaining some details to you. Let's say for assert equals, let me use a slightly different color. So when we say assert equals over here, right? And then what we want to do is e.toString. You can see here the context object is actually e, right? That's a context object, which is entry objects. Oh, let me just highlight it. E.toString. So now, which version of the toString method are we going to call? Well, indeed, we're going to call the toString method of the entry class over here. That's the toString, right? And the return value is expected to be in this entire long string. But let me illustrate some point which I mentioned verbally in the earlier video. Okay, what I said was this expected value over here. Part of it is expected from the toString method that's called on the underlying products objects. Okay, so let me now be a little bit more precise. Okay, let me make it larger here. Okay, so what I meant was this part over here is really worth for you to think about precisely. So this should be the return value from. So now we're talking about the context object e, right? E dot products, or you can say get products as well, but conceptually you can think about products, right? If you write this in Java, it may not work because e dot product is actually a private attribute. So unless you actually do it in the same entry class, otherwise it wouldn't work. But anyway, so conceptually we're saying e dot products dot to string. So this is really important for you to understand this particular value. So let's see how the code tracing will work. For example, you can see here when we execute the toString method, this over here is a context object, which is e. So this will be e and e over here. And now if you see that it's exactly e.products.toString, which means it's going to be e.products dot, which will identify this particular product objects, and then toString is going to call the toString method that's defined in the product class, which we went over in part 1 of the video. And that one is going to print out, for example, iPad Pro 12.9 over here, space gray over here, and etc. All right. Let me illustrate also this point to emphasize again back in the Eclipse. Let's now do that very quickly. Okay. So how do I see that? Everything here is good. And there's one more thing I would like to annotate very quickly. So now you can see for P over here, the objects is storing the objects of some product objects, and the product objects, we don't really see the address anymore because we already redefined the toString method. But you can see the ID, which will be very useful, is actually 56. So what I will do is I'm going to put 56 over here, right? So this will be 56, just for unique identification. Well, we might use this 56 a little bit later, okay? And then I want to go over, just say step over here, right? So if you try to do e.get serial number, you can also try the expressions over here if you wish, but I can definitely remove everything else from before. So I can say remove all, right? So I can start writing some new expressions. So I can say over here, e.get serial number over here, right? So that's exactly the number. You can compare that with the expected value. That's definitely pass. Okay. And then another one that will be interesting to see, e.get products. Okay, you can see e.get products is giving back to you some product objects, right? You can see that's exactly the structure of a product object. And what's its ID? ID is 56. On the other hand, if I also put P, which is the right hand side, right? You can see this is the left hand side, e.get products, which got the product objects of ID 56, right? You can see 56 here. And for the right hand side, is actually here the object variable p, which also store the address of some product objects of ID 56. So that's why equals should really pass. All right, that's also something I want to show to you on the debugger. And similarly, assert the same is going to pass as well. And now I want to do a little bit of further tracing for this one here, right? What I promised to you was this particular substring. This particular one actually comes from e.products.toString, right? That's what we have. And here, if you simply say let me try, maybe work e.products.toString. Okay, let's see if that will actually be this one will not work, simply because, as I said before, product is actually a private attribute. So this particular expression e.products, you can only get access to a private attribute only in that defining class, which is entry. So in this case, we are outside the entry class. We are now in the JUnit test class, so that's why we can now write it. Alternatively, you can say this. Rather than products, we know that it will be equivalent in this case to say get products. Right? If you say that, you can see this string value over here is exactly the same as what I just highlighted over here, the substring. Right? Let me show you even more. Right? I'll try to be very, very precise and complete. Hopefully, you can really see that. And let's now step into. I want to step into and see exactly which toString method is going to be called, right? First of all, we're going to step into the toString method from the class of the context object, which is entry. Okay, let's now step into it. If I say step into, okay, so now you can see we are now in the context of the toString method in the entry class, right? You can see now the focus is the entry class. And we know that it will in turn actually call this.toString. This.product.toString. So we can write this expression and give a try. Okay. So this is actually the current entry objects dot. So now this time when we say this.product, it will be okay because now we are in the defining class of that private attribute. So that will be okay. This.products.toString. If we do that, you can see that's exactly the string, the substring I said before. Okay. But let me do one more step into. If I say step into, what can we predict to happen? What's going to happen is we're going to step into the toString method for the context object, which is this.products of type products. Okay. So now if I say step into over here, it got some string builder. That's okay. We can step out. We don't want to see this, so we can say step return. And then let's say step into once more, and we still got this. Let's say step return again. Let's say step into, we still got this. Let's keep doing this. Step return, step into, and step return, and step into. Now finally we are now into that particular expression. So now we're in the toString method of the product class, right? The string builder you saw before, that one was mainly just for the string concatenation in the first argument. So that's why we still step into that step. But if you want to skip it, just keep saying step return and also step into, as I just did. Okay. So now we got a toString method, and if you copy and paste this expression over here, like what we did in part 1, you will see exactly the substring. All right. But what's really important is we're now switching the context into this product.toString, the toString method for the product class. All right. Okay, I don't want to see this. I don't need to see line by line. We did that already. So I'm going to say step out, step return, and now we are fine, right? So this assert equals is also going to pass, right? All right. So hopefully so far so good about crystal clear of how the first products has been set to the products of the entry E, right? Let's now move on to the remaining two products slightly more quickly, so just for your complete understanding. Okay, the second product we're going to create is going to be stored into P2. What's really important is it's using a new keyword again. So that means a new address rather than ID 56, right? So far we got ID 56. It's going to different ID will be stored into P2. Let's try that. If I say step over, we're going to call this products constructor, which you know how to trace before. Okay, let me say step over. And now what's going to happen is if you look at P2, go back to variables and look at P2. And it's a different ID, which is good. That means a different object, 108. Let's remember that. And then let's say we don't want to see these. So what I will do is I'm going to put a breakpoint over here right before we try to change from P into P2 for E, for entry E. So now I can say step return, and now I'm here. Okay, I'll pause here a little bit, and let's see on the paper what has happened. Okay, just remember the ID is 108. Remember that. Okay. So what we will do now is we're gonna continue with the tracing. So for now, I'm going to have another one. Let me just use green maybe. So this will be another. Let me make it thicker. This will be the second product object I want to create over here, right? And then, of course, also with the relevant mutator methods to set its attributes. Let me do that very quickly, right? But you just need to know it's a different product objects. So I'll just paste the product object I got from before, and then let me change its color to be matching, so you will know it really got resulted from that line. So color, it should be green, like that. Okay. And let's now see the various attributes. iPad Air 649. So iPad Air and also 649. And also gold 64. So finish is gold and storage is 64. It's false 100.00. All right, and then the address of this new object will be stored into object variable P2. So P2 over here is pointing to this object over here. That's what we got so far. All right. Hopefully you're okay with that, right? I'm not going to bother you with exactly how this part is done into this object over here. That's something I did in the last video of part 1. You can refer to it if you got any doubts. Let's now try to understand this line over here. Okay, this line is very crucial. Let's now try to use a different color here, and let's say here, this one. What does it really mean when we say e.setProducts P2, right? So we're gonna try to create aliasing again, right? So e.setProducts, that means we want to call the setProducts method over here. That's what we want to do, right? And then you can see the context object is the entry E. Okay, so that means every occurrence of this is going to be replaced by E. That's easy. And also the argument now is actually P2, which is referring to this object reference variable P2, right? So what we will do is we're going to So what we'll do is we're going to you can see P2 over here. So this product will be replaced by P2. Not only that, every occurrence of product will also be replaced by P2. So what this boils down will boil down into is we got E dot products is assigned to P2. That's what's going to happen, right? So this will be very similar to what we said before. E.product is assigned to P is what we did when we first created the objects, but now we'll do some reassignment to do E.products is assigned to P2. It's really important for you to also see this line. So this is what we did the first time, and this is what we do in the second time, right? So how do we do that? According to our interpretation from before, like this, right? What's going to happen is E.products after the variable assignment is going to point to wherever P2 is pointing to. So E.products, currently it is following this pointer. However, we want it to point to wherever P2 is pointing to instead. All right. So what's going to happen is, let's see. I'm going to use a green over here. So P, rather than pointing to the E.products, rather than pointing to the P over here, it is now going to point to. Let me just try to draw in a way that may not be too messy. It's pointing to this object instead. And again, we got aliasing. What's the aliasing we have? Well, let's see. We got another aliasing over here. And the aliasing we have is, for this object over here, there are two names for that, or two paths to it. Either P2 or E dot products, which is really referring to this, right? Okay, I'll just say both P2 and E dot products reference the same object, right? After this mutated call, all right? And then, of course, after this, if you try to do the assertion, let's do them very quickly, okay? Just one by one, very quickly. The first one, if we try to do a serial number over here, E dot get serial number, here E is still referring to the same entry object, so the serial number doesn't change, so that will be okay. Okay. What about the second one? When we say E dot get products equals P, right? Let's not just do it, solve it diagrammatically. Very easy. E dot products is now referring to this particular object if I follow the pointer, right? So this is the left hand side, E dot get product. What about P? P is referring to these objects. Are they the same objects? Absolutely not. That's why we are saying assert false. Okay? And then what about the next assertion? If we say E dot get products and then P, well, the same, right? They are not the same object. So that's why I say assert not the same. On the other hand, if I say E dot get products equals P2, right? Let's see if this will actually be true. E dot get products is going to give you this particular object, follow the pointer, and is it the same object as P2? Indeed, P2 is referring to this object, so they are the same object. So that's why you can say assert true, and also you can do assert the same. And if you try to do assert equals, it'll be very similar. I'm not going to bother you again with that for the debugger or the method call, but I just want to point out to you over here. So here, this part over here will be the substring. Oh, let me just draw a little bit better. Sorry. So this part over here will be the description of that P2, right? So this will be the return value from E dot product dot to string. And however, specifically, here, let me just annotate a little bit even better. So you can see this part, E dot products is currently actually referring to P2. So that's why you will see the relevant information from P2. You can see, for example, gold. You can see gold over here. You can see 64. You can also see 64 from here. Similarly, let me do a similar annotation. Before, when we first talk about the previous one, before we do that, so E dot products is really referring to P dot products, right? That's why you see the P dot product, for example, space gray. You also see space gray over here. You really want to see the change of the pointers for the objects. Really important. That's why I'm doing this a little bit slowly, but I think this is really worth the time. All right, let's see the final one. Okay. And one more thing to show you very quickly. I think that will be also worth showing. Let's remind ourselves the ID, I believe, is 108, right? From my memory, 108. So that means currently, if you try to see E dot products, right, for the debugger, it should really give you 108 to tell you that it's referring to this object. Let's now verify that. Okay. Now, if you go back to the debugger, all right, what I want you to see is this. Go to expressions over here. I want you to pay attention to this expression, E dot get products. Currently, it is 56. Okay, you can see the debugger is right before we try to change it from P to P2, right? I want you to watch the ID over here, right? And also you can see currently it's still iPad Pro 12.9. Okay, if I say step over, it has changed to 108 over here, which is the iPad Air Gold 64, right? That's very important. You can see what we change in the diagram about from this pointer into this pointer. In the debugger, you will see the ID of the object changes from 56 into 108. All right, that's the main point I would like to go to illustrate to you. All right, let's put another breakpoint here right before we execute the final set products over here. We might want to change it one more time. I want to trace something interesting to you as well. And then I'm going to say step return. So now we are here, right? So currently E.get product is still 108. We haven't changed that just yet. But let's see how we can execute this line over here, right? Let me go back to the paper over here. So the final line I would like to illustrate is this. Let me use orange. set products over here. Okay, this one we didn't really create a new product object right away in order to use this method, because that particular method only requires the model and also original price, right? That's something I explained before in an earlier video. So how do we trace this code? So we are really calling the set products in the entry class, the overloaded version over here. So this is the set products method that we are calling, right? You can see this one should be iPad Air. So iPad Air, and also 649. So this will be 649. Okay, what that would do, as I explained before, is it's going to create some local new objects of products over here. So this one is going to be a P. So now I don't want you to get confused. The P over here is different from the P over here. They're simply in different scope. So I think it might be easier for me to simply say, think about this more like a local P, right? Just different P. Okay, and this one is going to create another product object with iPad Air and also 649, right? So you can see every occurrence of model is going to be replaced by iPad Air. Every occurrence of original price will be replaced by 649.00. That's what's going to happen. Okay, let's draw that quickly. So how do I draw this P over here? Let me just get another product object over here, and then let me change its color to be orange, so you will know which line it is resulted from. So orange over here, and then so this P over here, I'm just going to use a color to distinguish. P over here. Okay, like that. Again, this P is referring to the P in this context under this method. On the other hand, this P here is referring to the local variable P within the context of the method. They are simply different scope. So Java runtime will be able to distinguish between them to be distinct variable. They just happen to be the same name, but they can be distinguished for sure. All right. Let's now put down the attribute value very quickly. So iPad Air and also 649. So that'll be iPad Air 649, and then all the other values will be default value. So the finish will be null, and also storage will be 0, and it will be false for connectivity, and also 0.0 for discount value. That's something I also illustrated earlier in the test case in the earlier video. Okay, you can also refer to it. All right, that's good. And then the last line here is also very crucial. This products is assigned to P, right? So how do we interpret that? Every occurrence of this is going to be replaced by the context object, which is P. So what this will boil down into is, let me just write something here. Okay, so that'll be E dot products is assigned to P, the orange P over here, right? Let me also highlight this line over here as before. You can see this will be this third occurrence that we are trying to change the pointer, right? You can see that was the first occurrence, this was the second occurrence, so this is the third occurrence over here, right? So how do we do that? Let's now anticipate what's going to happen. E dot products is referring to this reference over here. Currently, you got to follow the green arrow. However, we're going to reassign that to wherever P, the orange P, is referring to, which is this object here. So that means we're going to change it to something like this. That's what we're going to do. Okay, let's do that. So after executing this line over here, so E dot products, rather than pointing to the green objects, it is now going to point to. Okay, let me just try to see what might be the best way to draw this. Okay, it's now going to. Okay, let me just try to create the minimum mass, if I may. Okay, it's now going to point to this object over here. All right. Again, we got aliasing. So now, can you see what aliasing is? This orange object now is being referred to by both the orange P and also, if you backward trace the arrow, it's going to be E dot products. Okay, let me write it down. So it's going to be aliasing. So aliasing both orange P over here, P and E dot products reference the same objects. You can see there are many details actually in this tracing example, so please go over that very carefully. Okay. All right, so that's the aliasing we have, and then let's go over the assertion, and then we are done. And then also show you maybe something in the debugger. Okay, so how do we see the assertion? First of all, the serial number for the entry E doesn't change, right? So if you follow that, E dot serial number the same. And then the next assertion, E dot get products equals P, right? So the P, by the way, you can see the P over here is really referring to the P here is really referring to the this P in the scope, right? In the test method. Okay. So now let's try that. E dot get products. E dot get products is now going to follow the orange pointer over here, and then the blue one on the right hand side is referring to this object here, right? So are they the same objects? Absolutely not. So that's why assert false and also assert not the same. Okay, so that's the first two assertions. And then let's go a little bit further. What about the next one? E dot get products equals P2. The same logic. Okay. E dot get products is now following the orange pointer over here. And what about P2? P2 is over here, right? P2. And are they the same objects? No. That's why you also see assert false and assert not the same. Final thing to show you in the paper, you can see this part over here, iPad Air, right? This substring over here. This part over here, you can see is referring to iPad Air, null for the finish, and 0 for the storage, and also 0.00 for the discount value. That's really correspond to exactly these values over here, right? So now we're really referring to that objects. So this part of the substring over here is really is really returned from E dot products, which is referring to this object over here. Sorry, let me just get a little bit better. E dot products, which is referring to this object here, and then dot to string, which is going to print out, exactly this substring here. All right, so that's about the paper tracing. I'm really hoping that it's clear to you, but you can feel free to watch parts of this illustration again. It's really complete, so you can watch any part if you like. Let me go back to Eclipse and see if there's anything else I want to say. Okay, the only thing I want to show you once more, you can see before we do e.set products over here, we got 649, right, over here. And then once we do that, let's say if I say step over, what's going to happen is e.get products is going to change to some new ID, like a changing to a product of different address. It doesn't matter what that value is, but it's what's really important is it should be different from 56. Also, it should be different from 108. Okay, if I say step over, you can see now it's 137, right? If you're interested, you can actually what you can do as an exercise if you wish. When I was pausing at this breakpoint here, you can step into this set products mutated method and then try to see what the ID is for this particular new local objects. I bet you it should be 137. Sorry, it should be 137. The ID over here. That's something I can let you verify yourself. And then if you go all the assertions, they should all pass, right? As we said before. All right. All right, that's a very complete tracing between the debugger and showing the correspondence with the paper. Hopefully you're okay so far. Okay, so in the next video, we'll start talking about multi-value reference type attributes.